All right, guys, welcome to this page of the notes, and what I want to do here is just make introduce you to this idea of dividing complex numbers, which we're going to do an example problem here in just a second. But before we do the example problem, I just want to quickly explain to you the way that it's going to work. It turns out that we're not actually going to be doing division, but instead, the way that we divide complex numbers is actually by multiplying the complex number by its conjugate. And we talked about conjugates back in Algebra 1. And hopefully, well, what I'll refresh your memory on here is this. Conjugate pairs, all you do to find a conjugate pair is you negate the second part of the number. For example, if you have a binomial that is x plus y, the conjugate would be to negate the second half of the number. So if you have x plus y, its conjugate would be x minus y. You simply change the sign of the second part of the number, right? So we're going to do the exact same thing here, but now we're going to call it a complex conjugate because we're dealing with complex numbers. So if you are given a plus bi, the conjugate would be a minus bi. Or vice versa, if you're given a minus bi, the complex conjugate would be a plus bi. Now, here's the way that division is going to work. You are actually going to be doing multiplication by the complex conjugate of the denominator. So if, for example, you had 1 over a plus bi, this is division. Division by a complex number. But instead of doing division, what you're going to do is you're going to do multiplication, but we're going to multiply by the complex conjugate of whatever's in the bottom. I don't care about the top, I only care about the bottom. Well, my bottom is an a plus bi. So I will multiply top and bottom by the complex conjugate. Well, since it's a plus bi, the conjugate would be a minus bi. And I multiply both top and bottom by that complex conjugate. What if instead you were given 1 over a minus bi? Well, in order to deal with this division, you're going to multiply by the complex conjugate, which means changing the sign of the imaginary part of the denominator. So we're going to multiply top and bottom by a plus bi and a plus bi. That's the way that division of complex numbers is going to work. We'll multiply top and bottom by the complex conjugate. So let's jump into one of these problems, which I've got for you here on this page of the notes. All right, so here we go. Let's take a look at this first one. And like we said, I am dividing complex numbers. I know it's a complex number because I have a real part and an imaginary part, right? The real part and the imaginary part. And I explain again how you do it. You're going to multiply the numerator and the denominator by the complex conjugate of the denominator. So here we go. Multiply top and bottom. Well, my denominator is 3 minus I. The complex conjugate, 3 plus I. So 3 plus I over 3 plus I. And here's what you're now going to need to do, right? We're going to need to multiply this guy out. I have 3 minus I, 3 plus I. I have 1 plus 2i, and 3 plus I FOIL, right? We're going to FOIL, which is why we just looked at multiplying complex numbers, because now we're going to need it here when doing division. So let's go ahead and FOIL this guy out. Here's what I'm going to wind up with. In the top, 1 times 3 is a 3. 1 times I plus I. 2i times 3 would be 6i. And 2i times I would be 2i squared. Looks like those I squareds are showing up again. And they should. We just FOILed, so you're going to wind up with an I squared. In fact, when you FOIL complex numbers, if you don't get an I squared, you messed up somewhere, you're going to go back and try again. You should always wind up with an I squared. Now, here's the reason we multiply top and bottom by the complex conjugate. What's going to happen every single time is because the signs are opposite, the middle terms will always drop out. Let me show you. 3 times 3 is 9. 3 times a positive I would be plus 3i. Minus I times 3 would be a minus 3i. And what I've got is 3i minus 3i, which of course is going to cancel each other out. But I'm not done yet. Let's finish. Negative I times I minus I squared, which makes perfect sense. I'm foiling. I better wind up with an I squared. If you don't, you messed up. So here's what should always happen. You should always wind up in the denominator with middle terms that drop out. If those middle terms don't go away, you messed up somewhere. Go back and figure out what you did wrong. And you should always wind up with an I squared and an I squared in both the top and the bottom. If you don't, you messed up, right? That's just the way foiling works. You're always going to wind up with an I squared. But we know what I squared is equal to. Remember, I squared is equal to a negative 1. So let's go ahead and combine like terms and go ahead and substitute a negative 1 for I squared. He's going to come out looking really, really nice. I'm going to have an I plus 6i should give me 7i. So I'm going to have 3 plus 7i. And then I'm going to substitute a negative 1 for my I squared. And so I have 2 times a negative 1, which would be a minus 2. In the bottom, those middle terms have dropped out, and they always will. Again, if those middle terms don't drop out, you messed up. Go back and figure out what you did wrong. And I wind up with 9 minus I squared. But I squared is equal to a negative 1. So I wind up with minus a minus 1, which of course would be a plus 1. Right. We're almost done. 3 minus 2 is 1. And 9 plus 1 is 10. Now, you can either leave your answer like this, which is perfectly acceptable, or you could rewrite your answer by splitting those fractions, or splitting the complex number up into its real part, 1/10, right, which is a real number, 1/10 is a real number, and into its imaginary part, 7/10 I. Either one of those are perfectly acceptable answers. I believe that on your homework set, when you're checking your answers, they're probably going to give it to you this way, if I remember correctly, but I could be mistaken there. So just be okay with either one of those solutions. I certainly will give it to you both ways on tests or quizzes or anything like that. I want you to be comfortable seeing it both ways. So let's go ahead and try another one of these. They don't have to be that hard. I could make them a little bit easier. Again, I'm doing division of complex numbers. I know they're complex numbers because I got 2i there. Then I have 3, which is my real part, and 6i, which is the imaginary part. So we got a complex number at the bottom, and we said you take care of that by multiplying top and bottom by the complex conjugate. Since it's a plus 6i, complex conjugate would be minus 6i. So 3 minus 6i in the bottom, 3 minus 6i in the top, and we go ahead and multiply this out. But be careful, this time you don't have foiling in the top, right? 2i is not a binomial. It's just one term. So this problem is much easier than the one we just did. You just simply distribute. Oh, sorry, hang on. I can draw better arrows than that. I just simply distribute that 2i through my parentheses, and I wind up with 6i minus 12i squared. All right. The bottom, though, the bottom is definitely foiling. I have a binomial and a binomial. So here we go. Remember, my middle terms had better drop out, and I better wind up with an I squared. If I don't, I did something wrong. 3 times 3, that's 9. I am then going to wind up with, let's see, it looks like I'm going to get a minus 12i and a positive 12i. And then I'm going to wind up with a minus 36i squared. Right, that's what I get when I do 6i, a positive 6i times a minus 6i. All right, well, I know that I squared is equal to a negative 1. So let's go ahead and do our substitutions here. 6i, negative 12 times a minus 1 is now going to be a positive 12. In the bottom, minus 12i plus 12i, those cancel each other out. And I wind up with 9. It's a negative 36. I substitute my negative I in there, and negative 36 times a negative 1 will be a positive 36. Now, I don't like this. I'm going to have to switch those guys, right? Complex numbers, the real number comes first. The imaginary number comes second. 12, of course, is real. 6i is imaginary. So they just need to switch places. 12 plus 6i all over. And, of course, 36 plus 9 would be 45. Again, you can write it... yes, you can, sorry. You can write it like this, or, like I said, split it up so that you have your real part and your imaginary part of the number, which would be 12 over 45 plus 6 over 45i. So be comfortable with either one of those. Guys, that takes care of all the problems on this page of the notes. If you head on over to the next page of the notes, we'll practice doing a few more operations with imaginary numbers, both addition, subtraction, multiplication, and division. So I'll meet you there.